Hey guys, here's what I'm trying to explain to you over the phone. Here's a typical steel rule die, wood backed. You got about a 1/4 inch showing, so it's not even as tall as the material that you're trying to cut. So we can't use anything like this. We have a bunch of dies like that. These here are open face dies. Sometimes they're called textile dies. But the challenge with these is you can see how thick they are, okay? Versus something like this, about 1 millimeter thick, less than 1 millimeter, versus like 1/8 inch. And as I was saying before, here's a test cut that I went and pulled out from another customer. They're cutting a 3/16 to 1/4 plexiglass. And like I said, it's gonna, on their test, that's why I brought it up with you. And it's at a 1/4 inch. The displacement of this much material has to go someplace, because that shoves in there, something's got to give, and what gives is it starts to crack like this. So if you heat it up, it's not as big of a deal, versus if you're trying to shove that down in through there. See how thin it is. It doesn't displace as much material with the die itself, so it's your better bet. But you can't go getting crazy with these here because there's no reinforcement on these. They can top reinforce them like they did this one, that still leaves enough room here for your material to go. So we're going to give it a shot on this here. We'll try cutting first this out of a corner. The reason we do that is because it'll displace out the sides and hopefully not crack down the center of this. And we'll try that first and see where we come up with. Okay, this is we're testing this out on our on a 40 beam, and like I say, edge is right there and here, and we'll see what we come up with. Go ahead. Okay, so you can see the displacements warp the board. Okay. Okay, cut all the way through. More than enough pressure. Wrong kind of die for this though. We should be using, something, depending on the shape that you're trying to cut, something thinner. It's going to cut through this a lot easier. So, go ahead and try and pull that off, Chris. Okay. Yep. And that's pressed in here now because it has a beveled edge, on both sides of this. So the more it goes in, the tighter this piece is getting. So you normally use ejection foam or ejection springs. Your die maker can make an ejection spring that will press this back out. So we'll try it with the square one next. Okay, here's your edge. Okay. That's 40 ton. You can probably leave it the same. No, put it the same height. Okay. Okay. Makes a hellacious noise. So, luckily, we're not getting any cracking around here. Around here, I allowed about a 1/4 inch there, a little less than 1/4 inch right there. So go ahead and yank that out, Chris.
It's a displacement right here.
Yeah, you can see, okay, the displacement's pushing it out and around here. But go ahead, just hit it. Okay. So there's a piece. Okay. There's where we cut it out of. So on the surface, I think we're good. You can see it's cutting down in part of the way. And then as it gets into the second half of it, because it's spreading it out, okay, that it's almost just snapping that part. A thinner die would be different, so we'll just do a little test right here with real thin die and see what happens here. Now bear in mind it's not welded or anything, but we'll just set it right here and give it a shot and see what happens. We're testing it now, this thinner stuff. We'll see how that goes. Okay. A little more pressure. A little more pressure. Okay, you can see we pushed all the way through now. No displacement issues because it's so much thinner. So, thinner steel rule, and I think once we dig this out, you'll see that it cuts all the way through instead of just half the way and then breaking the rest. So this gives me a rough edge on the bottom, nice edge on the top. This one will give you a nice edge all the way through. Okay, got it out. You can see the difference in the two pieces. One's breaking halfway, and the other one's not. The other one's just smooth all the way through. You can see that. So, that'll give you some ideas on how to have your die made, what kind of die you want to use, but there you go. This part right here is just because the die wasn't welded together, and that's what will happen too if you don't have welded edges. Okay, so the pressure's got to go someplace for the piece that you're cutting out. So I guess one of your bigger challenges is how you're going to get these pieces out. Okay, you can see the die's still stuck in there when we cut through. So
CJR Tech has been in the manufacturing business for more than a decade, with offices in the USA, Philippines, Korea and China. We are an international company with sales all over the world. CJR specializes in all types of specialized cutting machines, with emphasis on automated cutting. Nearly all of our machines are customer-built to customer-specific needs. CJR is not the only company in this market segment, but they are the only company that can make custom machines from 10 tons to 350 tons in a variety of table sizes and machine types. Today, CJR enjoys annual sales that nearly doubles all USA-based competition with the best warranty in the business and the best customer service anywhere. If you want to do business with a company that always answers the phone and values customer service over anything else, you're in the right place. Welcome to CJR Tech, a different type of company.